Okay, so the first thing is indices. Indices is coming from the word index, and index means power. You can also say it's a power. So if I say something like 2 to the power 3, so 3 is called index, or you can say power, and 2 is called the base. Okay, so in mathematics we use a lot of symbols. For example, all these plus, minus, multiplication, division, equal to, less than, greater than, less than, these are all symbols in mathematics. Similarly, this is also kind of symbol, or you can say notation in mathematics, where you can use them to save space as well as time. So 2 to the power 3 means what? 2 by 2 by 2. Basically, you multiply 2 3 times. 5 to the power 4 is 5 times 5 times 5 times 5. Okay, so you have to multiply 5 4 times. That is the meaning of 5 to the power 4. But in some cases, it's obviously very complicated if you do it like that. If you want to multiply, let's say 5 to the power 3 with 5 to the power 4, let's say, so you will say 5 to the power 3 means 5 by 5 by 5, and then 5 to the power 4 means 5 by 5 by 5 by 5. So how many fives are there? 1, 2, 3, 4, 5, 6, 7. So you can say 5 to the power 7, isn't it? But instead of doing this intermediate step, this is intermediate step. So instead of doing this, we can directly work from this step to this step if you know the rules, which are also called laws of indices. Now, these are all given in your logbook, laws of indices, but you need to understand as well. So the first law states that a to the power p multiplied by a to the power q is a to the power p plus q. So basically, when the bases are same, as you can see that this is a, and you are multiplying, then you can simply add the powers. So 2 to the power 3 multiplied by 2 to the power 7 can be written as 2 to the power 10. Similarly, you have law number 2. And instead of multiplication, if you have division, a to the power p over a to the power q, then what you need to do? You need to subtract the powers. Make sure you do top power minus the bottom power here, not the other way around. Otherwise, you will get the wrong answer. So example, 5 to the power, let's say 7 over 5 to the power 2 can be written as 5 to the power 7 minus 2, which is 5. So you can see that instead of solving this by expanding and then canceling and then getting the answer, we can directly use these laws for quick answers. Then law number 3 is, what if I have power to the power like this? Then in this case, you can multiply the powers. For example, 5 squared to the power 3 is 5 to the power 2 by 3 is 6. 2 multiplied by 3 is 6. So when you have power to the power, what you need to do? You need to multiply the powers. 2 multiplied by 3 is 6. Okay. So what exactly is happening here? So 5 squared to the power 3. So first of all, power 3 means I need to multiply 5 square 3 times, isn't it? So 5 squared to the power 3 means you multiply 5 square 3 times, like this. And 5 square means 5 by 5, 5 by 5, and 5 by 5, which will obviously give you 5 to the power 6, because there are 6 times you are multiplying 5 with each other. And that's the meaning of power to the power. So you consider first power, then you multiply 5 square, let's say 3 times, and then 5 square means 5 by 5. In this way, you have 5 to the power 6. Okay. Now, obviously, you don't need to do this. This is just for your understanding. Whenever you have power to the power, you can multiply the powers and you write down as one single power like this. So these are 3 important ones, but there are some additional laws as well, which are important. For example, law 4, which is a to the power 0 equals to 1. A to the power 0 means any number to the power 0. If the power is 0, you will always get 1. And obviously you can use your calculator. In your calculator, doesn't matter what number you choose, let's say 5,952, whatever. I don't care. If the power is 0, I can directly say the answer is 1. Okay. So whenever you see the power 0, you can write down the answer as 1. Okay. And you can try that. So this is something which is very useful in mathematics. Law number 5. A to the power 1 over q is actually qth root of a. Now, let's understand this with simple example. If I say square root of 5, what does it mean? Square root of 5 means it is 5 to the power half, which means the power is half. That is the meaning of square root in mathematics. So you learn two things. One is square root. Square root is different. When you say square root, the power is 1 over 2. When you say square, the power is 2. So it's a big difference between both of them. Okay. So what about cube root? So if you say cube root, then you use the same symbol, but you have to use 3 here. So let's say cube root of 5. So again, cube root of 5 means 5 to the power 1 over 3. Okay. So this is the law here, which tells you that if you're using this notation here, root, this is called root notation, and you write some number there, that means on the other side, you can write down this as a 1 over that or reciprocal of that number. Okay, like if I'm using let's say 5 here, and if I write, let's say 10 here. So what does it mean? It means 5 to the power 1 over 10. You can also call this 10th root. Okay, so this is just a notation, but this root notation means you are basically writing 1 over that power, 1 over 2, 1 over 3. So if there is no number written here, by default it is a square root. Square root means the power is 1 over 2. So this is another important law which you need to understand. Law number 6. It's pretty much the same thing. So what if I have root and you have some number here, qth root to the power p? Then you can directly say a to the power p over q. Now I will break it down a little bit because this is not something new, because it's related to the previous laws which you studied. Okay, so what is the meaning of root? Root means a to the power 1 over q, isn't it? That's the meaning of this part here. Okay, and then to the power p. Now you know that whenever there is a power to the power, you multiply the power. So if you multiply p with 1 over q, what you will get? You will get p over q. And this is how we get this. Okay, so it's not a separate law, but if you know this law, you can directly write down your answer instead of doing this these multiple steps. So power to the power means you have to multiply the power. Root means 1 over whatever is that root you are using. Okay. Law number 7. A to the power minus p, which means negative power. So what you will do when you have a negative power? When you have negative power, you flip it and then change it to positive power. Okay, so that is the meaning of a negative power. For example, if you have 5 to the power minus 3, you can write down as 1 over 5 to the power 3. So I started with a negative power here, but if you flip it, then it can change into positive like this, and vice versa. So if you have something like 1 over 10 to the power 7, you can write down as 10 to the power minus 7, the other way around. Law number 8. AB to the power p, a to the power p, b to the power p. Now this is one of the most important law in laws of indices. Why it is most important? Because a lot of students make mistake in this. So you need to understand this properly. And I will directly give you an example to understand this. So if you have 2x, y to the power 3. According to this law, what does it mean? It means that because you're using a bracket, so this power 3 belongs to 2, belongs to x, belongs to y, to all the terms inside the bracket. As a result, you will get 2 to the power 3, x to the power 3, y to the power 3. Obviously, 2 to the power 3 means 2 by 2 by 2, which is 8. So you can simplify as 8, and then rest will stay as it is. Okay, let's take another example. 3x square y z cube to the power, let's say 2. Okay, so what will happen in this case? It's the same logic. You are using bracket, and outside the bracket the power is 2 or a square. So that square belongs to each term inside the bracket, which means 3 square x square to the power 2 y square z cube to the power 2. Okay, so you can see that I'm putting square to each of the terms. Okay, so what will happen? 3 square becomes 9. This becomes x to the power 4, because power to the power means you need to multiply. 2 by 2 is 4. Y square z cube to the power 2 means z to the power 6. So this will be your answer. Okay, so important part is this bracket here, and then this part, which means the power belongs to each of the term inside the bracket. But this law only works in case of multiplication like this or division. So let's take an example of division, which you can call as law number 9, the last law. A over B, that's a division or a fraction, and it's the same logic. So the power belongs to both of these terms. So if you have something like 2 over x to the power 3, then your answer would be 2 to the power 3 over x to the power 3. And that's 8 over x cube. Okay. Now where students make mistakes, silly mistakes. So these laws you cannot use in case of addition or subtraction. For example, if I have x plus 2 whole square, you cannot say, let's write down x squared. I mean, 2 belongs to this, belongs to that. So x squared plus 2 squared. So the answer is x squared plus 2 squared is 4. This is wrong. Okay. Why? Because the law which I explain you here, this is only applicable in case of multiplication or division, transferring power to each of the term. You cannot transfer power to each of these term if you are doing addition or subtraction. So make sure you keep in mind this law only works in case of multiplication or division, when the terms here. So when you write here, for example, in this case, what do you have here? 2xy. What is it? It's 2 multiplied by x multiplied by y. So you can use this law here, and that's why we said 2 cube x cube y cube. Okay, and same in this case, this is division, 2 over x, 2 divided by x. You can use this here as well. So, but not in case of addition or subtraction. In case of addition, if you have x plus 2 whole square, it means x plus 2 multiplied by x plus 2, and then you can simplify. Okay, so keep this in mind that these are two different things. Okay, now let us try questions from the exercise. So I'm going to do some random questions. Some of the questions are very basic, so which they are just asking you to use a calculator and stuff, but I will focus on important ones, which is this one. So 100 to the power 3/2. So without using the calculator, how will you simplify this and get the value of this, let's say, number? Okay. So 3/2. Obviously, without using calculator, you cannot get the direct answer, isn't it? So it would be difficult. What is the idea behind this question is that you need to check what's the power here in the denominator. I don't care about the top one. I only concern about the bottom one here. So 3/2. So it's 2. So can you write 100 as a power 2 of some number? So what is 100? 100 is 10 square, isn't it? So I want a number whose power is 2 to get me 100. Now why? I'll explain you. So 100 first of all can be written as 10 square. And why I'm writing 10 square? Because now it's a power to the power. So I can use the law where I can multiply these two powers because it's power to the power. What is the law again? A to the power m to the power n can be written as a to the power m multiplied by n. That's the law. Okay. So what's the benefit now? So 2 multiplied by 3/2. So 2 divided by 2 basically you can cancel. So what you left with 10 to the power 3. And you know that 10 to the power 3 means 10 by 10 by 10, which is 1000. So without using calculator, you can simplify these questions. So let's try again. Another one. 125 to the power 2/3. So this number here is 3. How can you write 125 as a cube of some number? Now, can anybody guess? So keep your mic unmute now because I'll be asking quick questions. Yeah. So 125 to the power 2/3. In order to get rid of this 3, I need to write 125 as cube of some number. Exactly. 5 to the power 3. And for that, obviously you can use calculator if you don't know the direct answer, but you can obviously have some idea. Okay, I can try 5 to the power 3 or 6 to the power 3 or 4 to the power 3 and see if I get the answer or not. So 5 to the power 3 to the power 2/3. So 3 and 3 basically gone. So you're left with 5 square, which is 25. Okay, so let's try another one. 81 to the power 3/4. So what should I do here? So the hint is already in the question, which is here 4, and you need to arrange. You need to write 81 as 3 to the power 4 exactly. So 3 to the power 4 is 81 to the power 3/4. So this will cancel 4 and 4. So you're left with 3 to the power 3, and 3 to the power 3 is 27. Okay, let's try another one. 8/27 to the power 2/3. What you will do now? So the logic is same again, although you have two numbers, so that's fine. One way of doing this question is if you want, you can separate them. So for example, 8 to the power 2 over 3, 27 to the power 2 over 3. If you want, you can do this way as well. Otherwise, you can do it directly as well. It's all up to you. How I managed to separate this like this based on the previous law that I explained you here. This one. As I said, this law is only applicable in case of division and multiplication. So you remove the bracket and you transfer power to each number inside the bracket. So this is what I'm doing here. Outside the bracket, the power is 2 over 3. Outside the bracket, the power is 2 over 3. Okay. So therefore, you can bring this power to 8 and 27 separately. And you apply the same logic. So this is 3 and this is 8. So 8 can be written as 2 to the power 3. And 27 can be written as 3 to the power 3. So 3 and 3, 3 and 3 gone. So you left with 2 square here, and here you left with 3 square. 2 square is 4, 3 square is 9. So 4 over 9 is the answer. Okay, so this is how you can simplify this. Now let us move on to the next type of question, where they will ask you to solve the equation. So for example, 3 to the power x is equal to 81. So solve the equation means you need to find the value of x. So you have some unknown variable there. You need to find out the value of x. So what is the value of x? Again, you need to see what's here. So what's here? 3. So what you need to think is, can I express 81 as power of 3? So you can obviously use your calculator. You can see whether 3 to the power 3, 3 to the power 4 or 3 to the power 5 gives you 81. So 3 to the power 4 will give you 81. Why we are expressing 3 as 3 to the power something? Because now I can compare. So 3 and 3, the bases are same on both sides. So the powers has to be same as well. So x should be equal to 4. Then only this equation can be true, isn't it? Otherwise, you cannot say 3 to the power x is equal to 5 to the power 2. Doesn't make any sense because these bases are different, isn't it? So because the bases are same, 3, 3, so x has to be equal to 4 in order to work this way. So this is the basic question here, but let's try a little bit tricky one. 2 to the power x plus 4 equal to 128. Now, logic is same. You can see that it's 2 here. I don't care about the power at the moment. Can I express 128 as a power of 2? Because I have 2 base here. So what power I should use? Anybody? Seven, isn't it? So what is 2 to the power 7? It's 128, as you can use your calculator. And now the bases are same, so you can equate the powers. When you equate the powers, you will get a very simple linear equation, which you know how to solve it. How to solve this? So x is equal to 7 minus 4, which is 3. Okay? X equal to 3.
What happened to the 2?
Which 2? Yeah. So this 2 is the base, isn't it? So the logic behind that is that the base is same 2, 2 on both side of the equation. So the power has to be equal. The base is already equal 2, 2. So the power has to be equal in order to make this condition valid, isn't it? So what we are doing is we are equating the powers. Only the powers.
Okay.
Because the base is already same. Okay.
Yep.
So once you know that the base is same, powers has to be equal from left hand side to the right hand side. Otherwise, this equation is not going to be valid, isn't it? So that's the logic we are applying here. So let's take another example. 5 to the power x plus 2 equals to square root of 5. So what you will do here?
Get rid of the root. Turn it
How will you get
to
rid of the
5.
root?
You change it to 5 to the power of a half.
Very good. So that's why I explained you at the start that you should know what do you mean by square root. Square root means, because there is no number there, it means it's a square root, and that means the power is half. And now you can see that you have the same base, so the powers has to be equal. So x plus 2, the power on the left hand side, must be equal to the power on the right hand side, and then you can simply solve this. So half minus 2, which is minus 1.5 or whatever. If you want to write down as a fraction, you can write down as a fraction. Okay, so that's the logic. You need to understand the logic behind this. So we are trying to make both sides with the same base so that we can equate the power. Okay, that's the logic. Let's go a little bit more into deeper questions. So let's say 2 to the power x is equal to 2 to the power 7 multiplied by root 2. What you will do here? Logic is same.
Get rid of the root again.
Yes. The idea is you will say, okay, I have the base 2 here. Or let's write down this step first, 2 to the power 7. Root 2 means 2 to the power half. Now you will say, I have the same base here, here, here. But you cannot equate the power at this stage. Okay, so you cannot equate the powers at this stage. Why? Because you have two separate terms at the moment, isn't it? We don't want two separate terms. We want one term on the left hand side, one term on the right hand side. So first you need to simplify the right hand side using the laws again. So which law is applicable here? Which law is applicable on the right hand side? Yeah. Can you repeat, Rolf? Third. What do you mean by third one? Third one is the power to the power one. Is that one you're saying? No, it's not power to the power. You can look at that expression. 2 to the power 7 multiply. Dot means multiplication. 2 to the power halves. Third law is power to the power. Then you multiply the powers, isn't it? That's a different law. We don't have power to the power here. We have 2 to the power 7. So you need to add the power. So which is law number 1. A to the power m multiplied by a to the power n. In this case, you add the powers. Okay. So you have to clearly distinguish between the laws. Okay. So first law is when you have two separate terms in multiplication with the same base, then you can add the powers. So this will give you 7 plus half will give you 15 over 2 if you want to write down as a fraction. And now you can compare because you have only one term on the left side and on the right side with the same base 2. So you can say x should be equal to 15 over 2. So that's the answer. Okay. Let's try another one. 10 to the power x minus 3 equals to root 10 over 100. So what's the step?
Would you change the square root into a half?
Very good. First step is get rid of square root and change to 10 to the power half. And what else you can do?
Would you change the 100 to 10 to the power of 2?
Very good. So bring all the terms as a power of the number, which is 10 here. And then which law is applicable now? Because I don't want two separate terms like this. So which law is applicable now?
Would you take away the powers from each other?
Exactly. So because this is a division, so you need to subtract the power. So what is the law? A to the power m over a to the power n. It's a division law, so you need to subtract the power. But as I said, make sure you do top minus bottom power, not the other way around. Even if you're getting the negative answer, doesn't matter. You have to do top power minus bottom power, which is half minus 2. So half minus 2, if you want to write down as a decimal, I will straight away say minus 1.5, which is easier. And now I can equate the powers. So x minus 3 on the left, minus 1.5 on the right. So x equals to minus 1.5 plus 3. Okay, which is 1.5. So that's the final answer. So this is the kind of process which we need to follow. Okay, let's do a little bit complicated one. 49 to the power x, 49 over root 7. How will you do this one?
Change 49, and you can change 7 to 7.5, and then 49 to 7.
7, exactly. So now you have 49 and 7. So you need to decide, first of all, which one I can convert into 7, or I can convert 7 into 49. Obviously, it's easier to convert 49 into 7. Why? Because 49 means 7 square. So 7, because all of the bases should be same, then only you can simplify, isn't it, at this stage? So 49 is 7 to the power 2. 7 to the power 2 here as well. And square root of 7 is 7 to the power half. So on the left hand side, which law is applicable? This is power to the power. So you need to multiply the powers. So obviously 2 multiplied by x is 2x. And on the right hand side, you have division. So you need to subtract the powers. So as you can see that you are kind of using the same laws again and again, sometimes multiplication law, sometimes division, sometimes power to the power law. So these are the common laws which you are using. So 7 to the power 2x, 7 to the power 2 minus half. So again, I'll prefer to write this as 1.5. And now I can equate the powers. So 1.5 divided by 2, which will give you 0.75. Okay. Okay. Now, let's try this one. 2 to the power 2x minus 1, 16 over root 8 to the power 3. So, how will you do it? So you have three types of bases here, 2, 16, 8, which obviously we don't want. So how will you tackle this?
Would cube both 16 and the square root of 8?
Very good.
No, wait, you would change the square root of 8 to 1/2 and then cube.
Yeah. you can go either way. If you want, you can first get rid of the bracket. If you get rid of bracket, then you have to put power 3 on both of them. Okay, that's the important law which I explained earlier. So when you open the bracket, the power belongs to all the terms inside the bracket, especially in case of multiplication and division. Now you have three different bases here, 2, 16, and 8, but you have to make sure that all bases are same. So obviously it's easier to convert 16 and 8 into 2. What is 16? 16 means 2 to the power 4. And then you keep power 3 as it is. Root 8. So first of all, root 8 means 8 to the power half, isn't it? Now 2 to the power, 4 to the power 3. So when you have power to the power, you multiply the power. So this becomes 12. This 8. 8 means what? 2 to the power 3. So 2 to the power 3 to the power half and then to the power 3. Okay. So you have three powers. Doesn't matter. Power to the power to the power means you have to multiply the powers. So what you will get? 3 multiplied by half multiplied by 3 will give you 2 to the power 9 over 2. Okay. Power to the power to the power means multiplication of the powers. Now you have division. So division means you have to subtract the powers. So 12 minus 9 over 2, which will give you 24 minus 9, which is 15, isn't it? 15 over 2. Or if you want, you can write down as 7.5. So now you can equate the powers. So 8.5 divided by 2 will give you 4.25. Okay, so first we get rid of the bracket. So you transfer power 3 to each of the terms like this. Then we change everything to the power of 2. So 16 can be written as 2 to the power 4. 8 can be written as 2 to the power 3. But in the denominator, you have 2 to the power 3 and then to the power half because there was a square root. And then you have a power 3, another power 3 here because it was there. So power to the power means you multiply the powers. And this is how we solve this. So let's take. Okay, so I hope everybody has paper and pen there. So I'm going to give you a quick question and let's see if you can get the answer. So question is this. Okay, so can you solve this? I'll give you 3 minutes. It's 7-2 at the moment. So you have 3 minutes to solve this question and tell me the answer. Answer means value of x. Sorry, how much? X equal to 1. Okay. So Rolf got the answer, x equal to 1. So let us verify that. So I'm going to quickly do this, and you can verify your solution as well as answer. So 25, 125, and 5. So you need to think what should be the common base for all of them. So it's 5, which you can use it. So this becomes 5 square, and because you have x power there, so it becomes 2x. 125 can be written as 5 cube, and square root means the power is half, and bottom it's cube root. So cube root means power is 1 over 3 to the power 12, which is already there. It's up to you. You can transfer the power first and open the bracket, or you can do this way. So it doesn't matter. Both will give you the same answer. So this is power to the power. So this will give you 3 over 2 and 5 over 1 over 3, and then to the power 12. And now we can transfer the power to both of them. So 3 over 2 times 12 and 1 over 3 times 12 as well. So this will give you 18. So 3 over 2 multiplied by 12 will give you 18. So you can obviously use calculator, but it's a simple calculation. 2 ones are 2, 2 6 are 12, 6 by 3 is 18, 3 4s are 12, so you left with 4, 5 to the power 4. And on the left hand side, it's 5 to the power 2x. Now I can use the division rule, which means 18 minus 4, which will give you 5 to the power 14, 5 to the power 2x. And now I can equate the powers. So 2x equal to 14, x equal to 7. So Rolf, your answer is not correct. Answer is 7. Okay, so sorry. Oh, look. So you need to be careful. Read question carefully. So Rolf forgot this power here, number 12. Okay. So write your question carefully and then keep on simplifying like this. Okay. So that's fine. Anybody got the answer? The same answer? 7?
Yeah.
Princess, you got it?
Yeah.
Okay. Now,
I did too.
huh? Tola?
I said I did too. I got 7.
You got as well. Okay, that's perfect. Sounds good. So the next type of question is basically based on two equations. Or before that, maybe we can try this one. So solve again, and the question is 3 to the power 2x plus 3 to the power x equals to 90. Now, if you look at this question, and you can see that you cannot simplify the powers directly. Why? Anybody can guess why you cannot simplify these powers here, 3 to the power 2x and 3 to the power x? Sorry?
As an equation and not an expression?
Yes, it's an equation, but
Is it
previously
because
also we solved an equation.
oh, then I don't know.
So the reason we cannot solve or using the direct laws which we studied is because of this plus sign here. Did you study any law which will help you to simplify this? No. Just for your reference, first law was a to the power m multiplied by a to the power n, which will give you a to the power m plus n. So what is the sign in between? multiplication. If you have a to the power n over a to the power n, then you have a to the power m minus n. So what's the sign in between? Division. And then if you have power to the power, then you will get power multiplied by power there. So obviously this is power to the power. So you can see that none of these laws are applicable in this case. And why? Because of plus sign. Okay. So this is the second type of question which you need to understand, and also you should be able to recognize why I can't solve using the laws straight away. So very interesting question, and this is exam, obviously exam type question straight away. So this question is actually a quadratic equation. How it is a quadratic equation? You will see. So first of all, I will bring 90 to the left hand side just to make right hand side equal to 0. And now if you see closely, this is actually a quadratic equation. Quadratic equation is what? Quadratic equation in 3 to the power x, because 3 to the power 2x can be written as 3 to the power x square. So 2x means multiplication of power. So I'm working backwards using this law, the third law. Okay. So I'm writing 3 to the power 2x as 3 to the power x square. I'm not doing anything to 3 to the power x. I'm not doing anything to 90. So you can see that this is looking like a quadratic equation. And for your convenience, just separately assume that 3 to the power x is equal to u. Just for your convenience, u, v, w, whatever you want to assume, doesn't matter. Why? Because now you can say this is u square, this is u minus 90, and this is looking like a quadratic equation. Well, it is a quadratic equation now. Okay. And you already know how to solve a quadratic equation. How to solve a quadratic equation? So generally we multiply this number with this here. So at the moment it's 1. So it's 90. And then you do factors of 90. So what are the factors of 90? 10 by 9. Now you don't need to find out all of them, because if you think this is working, so you can just use it. Now factors of 90, 10 and 9, and 10 minus 9 will give you this middle term, which is plus u or plus 1, isn't it? So this factor is fine. And because you are using this one, so you can directly use like that, u plus 10, u minus 9 as your factor. What you do after this, you put each factor equal to 0. So u equal to minus 10 and u equal to 9, isn't it? So you got two answers, but that's for u. We are not interested in u. We are interested in x at the moment, isn't it? According to the question. So we will again replace u with 3 to the power x. That was our original substitution. So we will say, okay, if u is minus 10 and u is 9, then 3 to the power x equal to minus 10 and 3 to the power x equal to 9 as well. Okay. Now, how will you solve? Let's solve this one first. This is straightforward. So how will you solve this one, this equation, and get x value?
Change the 9 base to 3.
Exactly. So 3 to the power x, and this should be 3 to the power 2, because the base is 3 here. So this should be 3 as well. So based on that, you can say x equal to 2. We got our first answer, which is x equal to 2. Perfect. What about this one? How will you do this? You cannot express 3 as, 10 as the power of 3.
Would you change it to 3 to the power of 1 over 10?
Now, if you are saying 3 to the power 1 over 10, that's not 10, is it? 3 to the power 1 over 10, you said, isn't it? So if I say 3 to the power 1 over 10, sorry, yeah, 3 to the power 1 over 10, it's something like 1.116, but that is not there. It's minus 10 there, isn't it? So the idea is this is not possible. Why? Why this solution is not possible or it's not valid?
Because any power of 3 won't give you 10.
No, because any power of 3, in fact, any power of any number will not give you a negative answer. Problem is not 10 here. Problem is this negative answer here. You cannot do 3 to the power anything. You know, try any number, doesn't matter, 1.5 or 3 to the power 2 or 3 to the power 1 or 1.2, doesn't matter. You will never get a negative answer, isn't it? This will never give you a negative answer. Can you get a negative answer? Even if you try a negative power, you cannot get a negative answer, because 3 to the power, let's say minus 3, means 1 over 3 to the power 3. According to the laws of indices, negative power means you flip it and change it to positive, and this is always positive number. Doesn't matter, it will give you 0 point something or something, isn't it? So logic is 3 to the power any number you choose cannot give you a negative answer. We are not concerned about 10 here. Obviously, if you have 10, like I think Princess, you said 1 over 10, isn't it? The power 1 over 10. Or Tola, who said that? Who gave that answer? 1 over 10?
I did.
Chola, isn't it? Yeah. So you can guess if there is a number like 10 there, then you can obviously guess and check in your calculator. Okay, if I try 3 to the power 1 over 10, can I get 10? You know, that's fine. That's possible. Okay. But you need to obviously check whether it makes sense or not. But because it is negative, there is no point of checking that, because you cannot get a negative answer if you choose any power. Doesn't matter, fraction, decimal, or a negative power, it will never give you this minus 10. Okay, you can get a negative answer if you have something like minus 3 to the power 3. That's a different thing. Minus 3 to the power 3 is minus 27. Why? Because minus is here. But you cannot get a negative answer using any positive negative power or a fraction power or a decimal power. You cannot get that. Okay. In order to get a negative answer, your number has to be negative. Then somehow you can get a negative answer. Okay. So that's why you just have to say this is invalid. So the only answer which is applicable here is x equal to 2. Okay. So what is the moral of the story? Moral of the story is that when you see this kind of question, when you see this type of question with a plus or minus sign, and if you see something like 3 to the power 2x and 3 to the power x, it's a quadratic equation. So how to solve this quadratic equation? So for simplicity, you can assume this as u, 3 to the power x as u, and then you will see a clear quadratic expression there, and you know how to solve quadratic. Okay, and then you can solve it, and then you can work out the answer. So this is how you need to do it. Now there is another question, just to show you. Obviously you can try later. 2 to the power 2x, 2 to the power x minus 6 equal to 0. So you can see that this is again a quadratic in 2 to the power x, like that. So separately you can assume as 2 to the power x as u. So this will give you u square u minus 6, and then you can solve this. Okay, so you have to get familiar with these type of questions, so that when you see in the exam, you should be able to say, okay, look, this is a quadratic equation type question. So every chapter, it's not only this chapter, in every chapter in mathematics, you will find 5 or 10, let's say, types of question. You need to just make a list of that. Okay, this chapter has this type of question, this type of question, this type of question, and this type of question. So this is how you need to strategically think when you're doing any chapter. Okay, otherwise you will see, oh, too many questions in the book, too many questions in the exam paper, you know, but your mind is kind of considering all these questions as a noise, but there is a pattern there which you need to understand. Okay, so this way you can limit your practice as well. So you don't have to practice maybe 50, 60 or 100 questions every week. You can limit 20 questions, but you try 20 questions which are completely different in their kind of concept, and just practice those ones, so that you can recognize when it comes to the exam. Okay. The same type of question with little tweak. So something like this. 2 to the power 2x plus 1, 15, 2 to the power x minus 8. Now you will see it's again kind of quadratic, which it is, but there is some problem caused by here, isn't it? You have 2 to the power x here, fine. You have 2 to the power 2x as well, but 2x plus 1. So how will you get rid of that plus 1 so that you can properly write down this as a quadratic? Any guess? So how will you get rid of plus 1? Because I cannot write down this as, let's say, u squared until unless I get rid of plus 1. That's a problem for me. Okay, the hint is you can use laws of indices. Okay, so I want to get rid of plus 1. So I need to break it down as 2 to the power 2x times 2. Or you can say 2 to the power 1, isn't it? 2 to the power 1 is 2. So if you put 2 to the power 1 or just write 2, it doesn't matter. It's the same thing. But this is how you can break this using your first law. A to the power m multiplied by a to the power m is equal to a to the power m plus n. So I'm working this way. So I'm just splitting 2x and 1 as 2 to the power 2x and 2 to the power 1. So in this way, I can now write down this as 2 to the power x square, and this will turn into a proper quadratic when you say u as 2 to the power x. So this will give you 2u square, 15u minus 8. Okay, so that 2, that extra plus 1 is giving you this 2 here. That's the idea behind this question. Okay, so when you say 2x plus 1, and if you break it, you can just separate like that. And after that, you know how to solve a quadratic. So 8 multiplied by 2 will give you 16, and factors of 16. So 16 by 1. Now I don't need to do, I don't need to use other factors, because I know that minus 16 plus 1 will give me minus 15 here. Okay, so that's fine. But since I have 2 here, so I need to properly solve this quadratic just to get the right answer properly. So 2u square and split the middle term using your factors. And then what you do, you make 2 groups. From the first group, 2u is common. And from the second group, nothing is common. So you just say 1. You're left with 1 u minus 8. U minus 8 is common. So you're left with 2u plus 1. And then you put each factor equal to 0. So this will give you u equal to 8. And this will give you u equal to minus 1 over 2. And what you do at the end, you need to again write u as 2 to the power x and minus 1 over half. As you can see that this solution is again negative. So you just ignore it. Because you can say 1 over 2 as 2 to the power minus 1, but minus is a problem there. So that's not possible. And here you can simply say 8 as 2 to the power 3. So x is equal to 3.